Hello, this is the automatic transmission. It's the first transmission that we're going to go through in this class. It is a 41TE used in Dodge, Chrysler vehicles, FCA vehicles. It's actually, I'm filming this in 2020 and this transmission has been around since 1988 and a half. I think it came out in a Chrysler New Yorker way back when. It's a long time ago. And they actually still use this transmission in the Dodge Journey in 2020. It's still a 4-speed 41TE is the available option for that. I guess they're just holding on to that until they decide to quit making that vehicle, but this is, believe it or not, still being used in production today. And we're going to go through and take this thing completely apart and overhaul it. Go through the motions just as if we were going to rebuild this one. The reason why I picked this transmission for this class, because it is about the simplest transmission we've got. There are some things that are complicated about it, but the valve body's real simple. It's only got 6 valves in it, 5 on the older ones, 6 in the newer ones. The gear set is just a compound gear set. It's got 2 simple gear sets in there. There's 5 clutches in this. There's no bands, no one-way rollers or anything like that. Just 5 clutches. 2 of them are holding, 3 of them are driving. So to understand this thing conceptually, it's actually a pretty good transmission to go through and look at for the first one, because just about everything else is more complicated than this transmission. They do have, like I said, some weird things going on with it, like their input drum's got a million snap rings to it and a bunch of seals. And I challenge you guys when you're going through this to try to figure out what those seals do and how these snap rings kind of situate and all that kind of stuff. And you'll see that when it comes around to it. Which brings me to the next point right here. We do have, up on D2L, there is a 41TE service kind of a packet, if you will. It's basically the sections of the service manual that I'll want you to follow along with. And also there is a 41TE overhaul worksheet. So you'll want to fill this thing out as we go along to make sure you are answering the questions. They're designed to go together. So one doesn't replace the other. You have to kind of go through the service manual pages and then check yourself as you're going through with the worksheet. Make sure you don't get too far ahead on the service manual and forget to answer some of the questions in the worksheet. Like one of the common ones that people miss right here is measure input shaft end play. They get carried away taking things apart and then they end up having the input shaft on the bench. It's like, did you check the end play? Nope, they forgot about it. So then we have to deal with that just going together with it. So I want you guys to use the service information and the worksheet in conjunction with each other, so you do that together. I've got this transmission mounted on this fixture right here. This is the engine side where the engine bolts up to, so it's kind of facing straight down. The front of the engine would be straight there towards the ground. So going around this thing, look at what we've got. These are cooler fittings right here, so the fluid's going to get pumped out of here, go to an oil cooler and come back. This is my input shaft speed sensor. That's my output shaft speed sensor. This connector here connects to the inside of the transmission where the range sensor is and where the temp sensor is. This is a solenoid pack, so our 4 solenoids that we have in the transmission and the 3 pressure switches, they're located in there. Coming around, this is something I added to it. We were doing a little experiment with this and I was using it to measure transmission fluid temp. There's the oil pan. Underneath this is the valve body. Up here on the top we've got a cover, and this cover houses these gears. We've got an output shaft gear and then a transfer gear. We actually won't take anything apart from here down. I'm just trying to get this as a basic unit, basic setup. We're not trying to get too carried away with this transmission. Really just to kind of get our hands on these parts, learn clutches and all that. The differential assembly, the axle part of a transaxle, is found behind this cover. And once again, we're not going to take that apart. So let's start by taking these covers off. It's a good idea to do that in the beginning just so we can get fluid draining. I'm not going to pull the differential cover off back here. I'm just going to pull the end cover off and then the oil pan off. Some of you guys will be asking me, can I use an impact gun? I got this cordless impact or something like that. I don't want you using impacts. The reason why is these transmissions, like I said, the first one came out in 88 and a half. I've got some old transmissions and they get taken apart every year. So I don't want anybody using impact because even though I got a setting on it and whatever, there's a much greater chance of you stripping these threads out if you're using an impact to blast them on and off. Even if you're taking them off, I just want you to use, doesn't take that long, just go ahead and use a speed wrench or a ratchet. So you can see there are my transfer gears right here. This is the output transfer gear. This assembly right here is a retaining assembly to keep that bolt from loosening up. You can go ahead and pull the oil pan off. The very first thing we do on the worksheet is this case inspection, and we look at the accumulators for the underdrive clutch, overdrive clutch, low reverse clutch. That you're going to see we have to take the valve body off to actually get to those. So we haven't gotten to that point where we have to fill anything out on the worksheet yet. The speed sensors are variable reluctance type. They just got a permanent magnet with a coil of wire wrapped around them. A lot of times when technicians pull these out, they take a look at them because these are magnets. They are magnetic. That if there's a lot of metal on the end, that's going to give them an indication of what they're going to possibly find when they get into this transmission a little bit. So that is a clue. So this right here is the solenoid pack, a little gasket. Earlier versions of the solenoid pack used a spacer plate underneath here, but the newer ones, they just have a gasket. So if you're working on an old transmission, you'll see there's two gaskets and a metal plate, but they revised this and eliminated that plate. So now we're going to go ahead and pull this valve body off. Start by taking the filter out. If you notice, I got a bunch of torque screws here. I don't have to take the torque screws out. I'm going to focus on these 10 millimeter headed bolts. If I take the 10 millimeter headed bolts out, I can pull this whole valve body off without having to, if I pull these Torx bolts out, I'll have all the check balls and spacer plates, there'll be more to it. Interesting thing about this transmission is when it first came out, it was such a bad transmission. There were like class action lawsuits about them. They barely made it 30, 40,000 miles before failing. And then right around 1996, what they ended up doing is they improved the computer, the processing side and the software. And that alone improved the durability of this transmission greatly. There are hard parts, things they've changed. Generally, when you're loosening bolts and you're taking something off, you want to kind of work around the outside and spiral in. And then if you go to tighten them, you want to start on the inside and spiral out. And especially, I mean, if you have a torque sequence, you can follow it. But if you don't have a torque sequence, that's a general rule of thumb that you want to kind of follow. If it's kind of hard to come out, the valve body, it's because they've got O-ring seals around this range sensor kind of plug assembly that's poking through. Also, you've got some seals on the shaft. So I usually kind of push in on those things when I pull that valve body out, and that kind of helps it come out. It's also possible that this one, yeah, this is coming out easy. But sometimes the shifter fights you a little bit. Like if it's in park and it's in all the way, you might have to rotate this to get it out of park. This is the parking pawl. This is the part that'll slide in there and lock this transmission in park so that it can't rotate. This right here is a seal that seals off on a drum assembly. Oil pressure for the 2/4 clutch is going to come in, stroke this accumulator, and find its way right into that clutch housing. And here's the range sensor. It's basically going to use these little connections that we have in there and ride on this plate, and that's going to tell the computer all the different positions of the manual valve. It's going to be in park, reverse, neutral, low, all that kind of stuff. Okay, so we're making our way through this. You can see the next step in the service manual is going to have us deal with the accumulators. Underdrive and overdrive accumulators right here in the case. And if you take a look, the springs are in there and then the piston. That's the correct way they're assembled. Now these, on the worksheet, you're going to have to fill out the color. These are just natural color. They don't have a color to them. But if they were blue or pink or something like that, you'd identify that. So this is where my low reverse accumulator is. And you can see there's a cover on there, and I got to take the snap ring out. That little raised section there in the middle, that's there so that way you can get a pair of pliers on it and yank it out. Sometimes if you aren't paying attention and you put that piston upside down, it's smooth and it doesn't, it's kind of, you have to use air pressure to get it out. So there we go, we got the snap ring off. The easiest way to get that piston out is put a little petroleum jelly on the end of a socket, push against it, and it'll kind of stick it to it and pull it out. You can see these were installed with the spring, then the piston. That's why we had that flat surface that was exposed after I pulled the plug. You can also notice this one has 2 springs in it. They're all natural colored, so we don't need to identify colors, but we do need to remember that the double spring went in the low reverse. At this point, we need to check input shaft end play, so I'm going to swing this transmission around. If you are using a fixture, be real careful because obviously all the weight is on one side of this fixture, so when you try to rotate it and it gets to the side, the weight of it's going to want to carry it around. Also, never put your hands in between these like little arms, because if it ever tried to pivot and your hand was in there, it's going to work like a scissors and probably cut your fingers off. So keep your hands or anything out of the inside of that. Alright, so we're going to check input shaft end play, which requires me to use a dial indicator and clamp that to the transmission housing. So there's a hole on the end of the input shaft, which makes it a little difficult to get the dial indicator on there because it has a tendency to want to kind of fall in that hole. So a lot of times I'll take a valve body bolt. I know they're not perfectly flat on the top. I might just lay that in there. I moved my clamp because it wasn't in a very good spot. This is a little better. It actually ended up at 0, which is amazing. I never really bother zeroing it out. I just look to see how much it changes when I lift it up and down. And you might need to grab a pair of pliers like I just did. This thing's not changing at all. Matter of fact, the input shaft doesn't even like to turn. I have a feeling it was somebody assembled this wrong last time and they got some clutches bound up in there. So this is good. We'll probably find something damaged or at least assembled wrong because there's no input shaft end play on this transmission. There should be, I think the spec is between 5 and 25 thousandths of an inch, but we're definitely going to make sure when we go back together with it that it has the proper end play. Okay, so next I can take that oil pump off. Ooh, I heard a noise when this lifted up, which means it was probably sprung from not being assembled properly. So there are a couple threaded portions of this pump, so you could take these pump pullers and thread them in. Kind of gives you the capability of slide hammering this out. The reason why you need to do that is because there's an O-ring seal around this pump and it's kind of tight, especially if it's been in there for a while. And there's no other real way of getting in there and pulling that out. So here's our oil pump. And it's a gear and crescent type pump. It pulls in fluid and pushes it out, and then the valve body does its thing and delivers fluid through these passages, and then these passages come out and deliver fluid pressure to the clutch housing, and to the torque converter clutch and lube circuits and all that stuff. So we'll put, matter of fact, I might just slide this down in here, because as we take things apart we could stack it up there. This is just a little gasket that separates the housing from the pump. Lives on there, and if you remember the O-ring I was mentioning is what can give you a little difficulty getting the pump out, and that's why we use that slide hammer. So this is the input drum assembly. All 3 clutches are in here, and this is what ends up driving the gear set parts. In the transmission case right there is a cooler bypass. So cooler bypass is a device if the oil cooler ever gets plugged. This is spring loaded, and once pressure rises because of the restriction, it'll move a check ball over and allows the oil to bypass the oil cooler because all the lube oil comes from the cooler. The torque converter creates heat, and then it gets pushed out of the torque converter and goes to the oil cooler, and then when it comes back after being cooled off, it gets pumped into the lube circuits. So if the oil cooler ever got clogged, the problem that we would have is that the fluid would never find its way into the lube circuit, and would not only, so whatever clogged the cooler is also going to cause the rest of the transmission to burn up because there's no lube oil. So they recommend replacing this pretty much on every job. Following along with the rest of the service manual, they have us pulling the front sun gear assembly out. We're going to pull this front carrier rear annulus gear out. Inside the transmission case is the 2/4 clutch assembly, and below that is the low reverse clutch assembly. This silver piece is the piston housing that compresses the 2/4 clutch assembly. So now we got to pull that out. In the service manual they show a special tool, this guy with a little press pushing down on it. that pushes down and relieves tension off of that snap ring. You definitely need to do that when you go together with it, but there's really not that much tension on it, and it'll come off fine without it. That housing will only pop up about maybe a 1/16 or an 1/8 of an inch at most. So there's our snap ring. I can reach in and grab that housing. So now that we've got that out, we can see this is the spring that was causing a little tension on that snap ring on the top. The piston is actually this piece right here. And there's some seals in there. We'll pop that out in a little bit, see what that looks like. And it compresses this clutch pad. So I've got the piston pushing against the steel and compressing in between. We've got 4 frictions and 4 steels. If you look, these steels are pretty thick. If I measure them out, and there's a spot on the worksheet to fill that out, how thick these steels are. In this case, these steels are almost 100 thousandths of an inch thick, and the frictions are like 80 thousandths. This is the 2/4 clutch assembly. They had issues with the shift from first to second, causing a shudder. And in the service bulletin, they say make sure the steels, the 2/4 clutch steels, are staggered. All right, so I've got all my steels. They look like they're pretty much the same. They're all stacked on top of each other. All the lugs are lined up. And if I look right here on this one section of lugs, and that's not the part that lugs in the case. I think it's really just there to identify it. If you look, it's kind of like stair-stepped right there. If I flip this over, you can see they're the same length. On this side, if I flip that one back over, it's like a magic trick. And it's staggered. You're actually supposed to put them in staggered like this. And like I said, I heard that these steels are not perfectly flat, and you stagger them so that way the non-flat portions aren't lining up with each other. But man, I don't know. If they're not flat, they're really close to being flat. Now further down in there, I've got a snap ring. It's a tapered snap ring. It's fitting on top of a steel plate, thick steel reaction plate, and then I got a flat snap ring underneath it. Whoever put this together put it together wrong. They put the tapered side facing down. The taper on the snap ring faces up. And if you look, there's a little bit of paint on this. It's like orange. They put the paint on the bottom and the taper is on the top. But the problem is a lot of people have a hard time seeing the taper. If you see me kind of shine that in the light, you can almost see a line down the middle. It's because only half of it has a taper. It's really like just this part out here. So with the tapered snap ring, the taper, it goes up, the flat side goes down, the flat side has that paint on it. They do that because they have kind of a tapered notch cut out of the case, and they want it to kind of fit snugly in there because it's actually going to pinch this reaction plate into place. That way they don't have to get real tight with their tolerances, with the thickness of these lugs, and also the snap ring grooves that they cut in the transmission case, because they can rely on that taper to kind of slide down that taper and pinch onto this reaction plate. So it's a thick reaction plate. It works with the 2/4 clutch on the top, pushing down, and it works with the low reverse clutch coming up, pushing up. And it's locked in place by the tapered snap ring on top and a flat snap ring below it. We got a clutch disc here. Get it out of the way so it makes it easier to get my snap ring out, the flat snap ring I was just talking about. There's a little flat snap ring, not much to it. It gets a little tricky trying to get the rest of these clutches out because the output gear is in the way, but you might be able to get a couple picks in there, kind of hook them. So here's the low reverse clutch pack. I got 5 frictions and I got 5 steels. Even though they would fit on the 2/4 side, the same size lugs and splines, the frictions these are a little over 70 thousandths, and the steels are like 65, 66 thousandths. So they're not interchangeable. These definitely have to go with the low reverse, and the 2/4 definitely have to go on the 2/4 side. All right, so now I can go ahead and pull the sun gear out, and it's got a little bearing in there. At this point, I've got the output gear set in there, but it's bolted in. We got to take the bolt off the back side of this thing and kind of take that output gear set assembly out. We're going to go ahead and do that. And that's as far as we'll take this apart, just because, like I said, this is a basic introduction. I don't want to get too deep into this first transmission. I'd rather you guys get a little experience studying how this one works, the clutches, the pump, the gear sets, and then move on to the next transmission and go a little deeper in that one. I'm going to take this retaining mechanism off. Good, one of the students left it loose. They didn't even need to get a socket for that. Well, this bolt's can be pretty tight. This is not going to be something I can just loosen up with a ratchet probably. Although since this has been off plenty of times before, we might as well take a chance and see if we can get that off. Now what I don't want to see anybody doing is sticking anything in here. That could chip the gears and so forth. If you need to keep this from spinning, now obviously an impact would blast that off, and I don't mind if people use an impact on that, but going through the parking pole, you can't lock this thing in park and then see how tight it got. But somebody probably put this together with an impact last, so okay, I got it. Now I loosen this thing up. I'm going to take the bolt loose pretty far. You can see how much thread I've got. I got tons of thread, so I'm going to go ahead and thread it back in to the point where like maybe a half of an inch is showing, and then I'm going to pound on this and drive it out. The reason why is because there's a interference fit and it makes it a little tight to get out. As it starts moving, I'll thread that out a little bit more until I know it's free. At this point I know it's free, so I'm going to put my hand in through this opening to keep the gear set from falling on the ground. And I've got the bolt out now. I can take the transfer gear, put it off to the side, and I can grab this and pull it out. This is a shim. You don't want to lose this shim. It keeps those two bearings separated properly. If I didn't put that shim in there, these bearings would try to crush right onto those bearing races. So I need to have the shim, and if it's the wrong shim, I'm going to have the wrong preload on this assembly, and that's not good. It's going to waste those bearings. All right, so at this point, this is as far as I expect you guys to take anything apart in this transmission case. Like I said, we're not going to take the transfer gear out. We're not going to take the final drive out. We're just going to work from here. We're going to work on the bench. And from the bench, we're going to study this gear set a little bit. And we're also going to take apart this input drum and inspect it, study the passages, measure the clearances, go through this real well. And we're going to take the oil pump apart and do some clearance measurements on it. And then we'll go back together with those things. All right, you can see that I've cleared off my bench a little bit, organized some tools, made some space for me. And one of the things you might notice if you're going through the service manual pages is that the numbers aren't necessarily in order. And I do that for a reason, because the service manual, if you follow it from front to back, they'd have you start putting clutches in and all that stuff. And we haven't even really taken anything like this input drum apart or this pump apart. So once everything's completely apart, I kind of divert our attention to the oil pump and this input drum assembly. And that's where the worksheet kind of heads. First thing we're going to do, and before we get into the input drum assembly, I'm going to just point out this gear set that we have right here. This is the gear set. I'll build it back up. This is a rear sun gear. This is the rear carrier. So the rear annulus gear is built in kind of to this front carrier rear annulus assembly. And if you look, the output is a rear carrier front annulus assembly. So it's a combination gear set. It's a common connections that you'll learn a little bit more about that in the PowerPoint that covers power flow. But so I've got a front carrier rear internal and a rear carrier front internal gear. Those are common connections. The output is always going to be either the front internal or the rear carrier assembly, and the rear sun gear. The rear sun gear can be driven by the underdrive clutch, and this front carrier rear internal gear assembly can either be driven by the overdrive clutch with a set of splines and a hub, or it can be held by the low reverse clutch. And this right here is my front sun gear assembly. And the front sun gear can be driven by the reverse clutch, or it can be held by the 2/4 clutch. So this is my gear set, from front to back. Basically, that's the size of this gear set. 2 gear sets, compound gear set. These 2 are my holding hubs, 2/4 clutch and low reverse. And then I've got 3 driving clutches. The reverse clutch will drive this part, and my other 2 hubs are in this input drum assembly. And that's where we'll go next. So before I take this input drum apart, I think I'm going to go ahead and air check it. When we air check a clutch housing, what we're doing is we're putting air pressure in the place that fluid pressure would normally go. And that way we can see if these clutches are applying properly and if these pistons and drums, if they're sealing properly. Now on this 41 TE, you are going to notice a bit of air leakage. It's not going to be a tight seal because there are air passages. Like when we study the hydraulics, you'll see for the overdrive and reverse piston, which is right here, that there's a hole that connects the 2. And so when I apply the overdrive, I'll have it leak through the reverse, and when I apply the reverse, it'll leak through the overdrive. And then the underdrive piston has a hole drilled in it too. The reason why they do that is to keep hydraulic fluid pressure from dragging a clutch on when that clutch isn't applied. They want to be able to take the volume of fluid that's in there and let it leak out, so that way as it's spinning we don't build up centrifugal force and end up applying that clutch. But it's always a good idea to check these things on the way down to see if you had any issues with it. So this one right here is going to check my underdrive, and my underdrive is going to be connected to this hub right here. I can hear the piston thumping in there. So this is the reverse passage, and you see the piston traveling up and down. It's actually compressing this top clutch pack. And then this is my overdrive clutch passage, and you'll see the piston travel down. It's applying the clutch pack that's below it. So that would be this hub. I spin that hub and apply that clutch. Now I'm going to connect it to the whole drum assembly. Also, when we air check this, we apply it with 40 psi or so of air pressure. You might see 30 or 40 psi. The reason why we use lower air pressure is because this leakage that we're expecting, if we had a lot of air pressure going in there, we could be still applying a clutch, even if it had a crack in a piston or a torn seal or something like that. But if we apply it with low pressure, that if you do have like a crack or if you do have a torn seal, there's less of a chance of it actually applying that clutch. It won't be able to build up enough pressure behind it to apply that clutch with that extra leak. So we use a lower pressure when we air test this because even though we're going to hear a leak, we're still expecting to see that piston apply and compress that clutch. Okay, so now we can go ahead and start taking apart this input drum. This top snap ring right here holds this top plate in there. It is a selective snap ring, meaning that it comes in a variety of different thicknesses. It might help to kind of use the screwdriver handle and push that top plate down a little bit. I don't know if you remember when I was checking the end play in this transmission that I didn't have any end play. This is the clutch that usually doesn't get lined up, and then when people put it together, they end up distorting and destroying this clutch. And let's see if that's what happened. We've got 2 friction discs for reverse. This is the first one, and it looks fine. It's flat. There's nothing wrong with it. Then we've got a steel plate. Nothing wrong with it. Looks good. And then this is the other friction, and take a look at that. It's dished. It's not supposed to do that. The reason why that happened is that when we install this input drum into the transmission, the only clutches that we have to line up are these 2 clutches. Obviously these clutches we just pulled out of the input drum, so when you're putting them onto the gear set, you have to jiggle the input drum around and get it to line up these 2 clutches right around this little section of the sun gear. If you don't get it in all the way and this one's sitting off and just didn't get on there, when you go to put the oil pump on, if you just tighten it down, you're going to bend this up. And that's what happened. If I had a nickel for every one of these that happened, I'd have like $5. This is the overdrive reverse apply plate snap ring, the top snap ring. The way this thing works is that I have a snap ring down here and a snap ring above this. These things kind of capture, they end up capturing this into this clutch housing, and when this piston goes down, it compresses the overdrive clutch pack. This plate compresses the overdrive clutch pack, which is down here. And when the piston goes up, this plate compresses the reverse clutch backs, which I just took out. So this housing is moving up and down, but what it's doing is carrying this plate and moving it up and down and applying that clutch. So let's take a look at our overdrive clutch. We've got, looks like we got 3 steels and we got 4 frictions. The frictions are about 70 thousandths of an inch thick, and so are the steels. The reverse clutch pack, same thing, 70 thousandths, a little less than 65 thousandths. One of the things to note about the snap rings that go in this input drum, that top snap ring that surrounds this reverse / overdrive apply plate, it's flat. It's a flat snap ring. But the one that lives below it, and really what it does is it serves as a ledge for this to sit on, so this plate doesn't sit on aluminum lugs. Well, this one that goes below it is wavy. So it almost looked like somebody drove over that with a truck. But it's supposed to be like that. The reason why they have a wavy spring on the bottom and a flat one on top, when this housing travels up and compresses the reverse clutch pack that lives above it, this is going to kind of cushion the apply. It actually provides a little bit of a cushion because these waves have to flatten out. And they do that on reverse because reverse doesn't have any accumulators. So they don't have any real ways of cushioning the reverse application, except they can mechanically do it with this wave plate. And they got some other tricks up their sleeve too. But okay, so these 2 snap rings capture that apply plate that's used for reverse and for overdrive. Now we go down a little further, and we're going to have another set of snap rings holding another plate down. This plate separates underdrive and overdrive. Like the snap ring in the case, this is supposed to have the painted side facing down, which it was, and then the tapered side facing up. And you can see it's kind of like the one in the case. The taper only lives on this outer edge. It's not the whole width, and you can kind of see that with the light reflecting on it, that it's pretty much glaring off only the outer edge of it because it's flat and then tapered. So this is the top snap ring. Then I could have pulled that out anyway, but then I pull my reaction plate out. Snap ring would have lived on top of that. That's kind of why that recess is there. Now this one, you'll see in the service manual, and actually you'll see in the worksheet where I always say, place the step side down. You're going to be like, well, wait a minute, there's 2 steps. There's a step on this edge, there's a step on that edge. So basically, you want to, if it has 2, not all of them will have an edge on this. The earlier 41 TEs were flat on the top, or they might have just a little chamfer. But you always want to put the bigger step facing down. This is a bigger step than this. So if you have a step, the bigger step or the step always faces down. And then under this, I'm going to go ahead and pull this friction out, just like in the case, so I don't damage this clutch disc trying to dig a snap ring out of there. All right, pull the snap ring out. I don't know how often people do this in the shop, but the service manual says you're supposed to replace these snap rings. The tapered snap rings I can understand. I think the early ones had a tendency of breaking. I don't think they really run into those issues on the later units. Okay, so here's my overdrive, underdrive pressure plate assembly. And like I said, it gets wedged into this housing by these 2 snap rings. Flat snap ring on the bottom, tapered snap ring on the top. Remember how I told you a while ago that this transmission has 1 billion snap rings? This is why I mentioned that. I'm just going to tip this input drum over to get these clutches out. So this is my underdrive clutch pack. On this we have 4 frictions and 4 steels because I took this friction out to kind of protect it while I was digging out those snap rings. And if I were to check my measurements here, you can see it's also almost 70 thousandths steel and 70 thousandths friction. These hubs grab onto the gear set components. It's easy to get these thrust washers kind of mixed up. There is like a smooth thrust washer attached to the inside there, and another thrust washer on this underdrive hub, on the overdrive hub. Allows them to fit together nicely. This right here is the selective washer that helps determine the input shaft end play. We didn't have any input shaft end play, but it wasn't because this washer was wrong. It was because whoever put this together last didn't have the input drum in all the way, and they ended up binding up against the reverse clutch assembly. So the underdrive clutch is going to grab onto this. The overdrive clutch is going to grab onto that. And then my reverse clutch will grab onto this. So our three driving clutches that we have are underdrive, overdrive, reverse. Underdrive drives this rear sun gear. Overdrive drives the front carrier, rear annulus. And reverse drives that sun gear. Well, we're not done taking apart this input drum yet. Now we took the clutches out, but we haven't taken any of the seals and inspected any of the pistons. So I'm going to go ahead and pull this out, and we're going to look at this a little differently. This right here is this next assembly that we're going to pull out, and there is a retaining ring that holds that in place. You got to use a foot press to push this assembly down to relieve the tension on this. If you don't do that and you just go in there and try to pop that open, this thing will blow up at you because there's a big spring behind this. And so you definitely want to use a press to push that down just enough to get that snap ring off, then you can let it up. And we'll go do that right now. Here I've got my input drum installed in the foot press. These little arms are going to push down on this piston, and it's going to give us enough clearance to get that snap ring out. We want to make sure there's no pressure up against that snap ring. There's a big spring behind that piston. So I'll use my foot pedal down there to push down on it, and that will push that piston away from the snap ring. We don't want to get too carried away. Realize that it is a foot press. Don't put your whole body weight on there and crush something. Make sure you got your safety glasses on. And there we have it. Okay, now that we got the snap ring off and pull this little piston retainer off. They call this a piston retainer. It does have a seal around the outside edge. But this isn't actually the piston that applies the clutch. This piston here retains this big old coil spring, and that seal makes the fluid that gets behind this piston, it gets diverted and kind of comes out through the center section here. And they do that on purpose because on the inside here, this underdrive piston, which is right, let me see if I can get that out by hand. The underdrive piston has this little hole in there, and that hole is a engineered little orifice that when there's fluid pressure behind it, it will actually squirt the fluid out through that tiny little hole. So the reason why this hole exists, though, is that when this clutch is not applied, mainly in fourth gear, that's about the only time it's really not applied when you're going down the road, they don't want fluid pressure to live behind this clutch. Because if this drum's spinning, centrifugal force is going to hang that fluid in there, and that fluid centrifugal force is going to kind of create a force up against this piston, and it might drag this piston on. So any of the fluid that gets behind this piston, they let it leak out through that hole. And then that fluid, as it leaks out through that hole, it's going to find its way back to the pan because there's no seal on the inside of this this little retaining piston. So that lives all there like that. Underdrive piston. They're just to apply the underdrive clutch. Now if we look at the inside of this, we have another snap ring, and it's holding this drum assembly together. That snap ring's right there. There's no spring behind it, so I can go ahead and pull it off. It does have a taper to it, so it might be a little difficult to get out, but it should pop off fairly easy. And this is something worth noting right now, is that we've got these two retaining rings. Even this one that goes on the top here that retains the underdrive hub, there doesn't appear to be a tapered side. It looks flat on both sides, but one side has a crisp, sharp edge, and then the other side feels kind of rounded. Not very rounded, but you could tell maybe the stamping process, the way it worked, that the way it stamped it out, it made a crisp edge on one side and a little smoother edge on the other side. Well, since this is designed to fit in a nice square cut groove, you probably want that square edge facing up because that is the direction that this piston's going to be pushing on, and you don't want this to pop off. This other clip has a tapered kind of intersection here, and that's designed to go up as you're looking into the drum. That taper is going to fit into that machine groove, just like the snap ring that goes on this input drum that lives on top of that underdrive, overdrive reaction plate, and just like the one that's in the case that lives between the low reverse and 2/4 reaction plate. It's tapered for a reason, so that we don't have to get real tight tolerances when they machine these grooves. They can let that taper kind of work as a wedge and slide in there and pinch onto these parts and keep them tight. So I'm going to use my hammer handle. I'm going to put my hand right here on the outside of this, and I'm just going to kind of tap the inside of this, and I'm going to let this whole drum assembly come apart. See how simple that is? You don't have to get too carried away. You could use a saw face hammer. I'm a little too lazy, didn't want to walk over to the toolbox and get it. This assembly right here is the input hub. This is splined to the torque converter. Torque converter is going to deliver that torque into the transmission, and it's going to spin this part right here. And we see a handful of seals. We've got this seal here. We got a red one, a blue one. There's a seal that goes around the inside of this, right there. And that's going to seal off on this surface. Remember I said how there's a lot of seals in this transmission, a lot of snap rings? Now you're starting to see. Okay, I'm going to pull this assembly apart. It's going to take it to the next level. And by the way, there's a special worksheet in the for this transmission where you guys study pretty much what I'm talking about right now. The purpose of some of these seals and oil passages and all that good stuff. Okay, so I have my input drum completely apart. I'm going to put this onto here just to show you, since that splines. This assembly splines to the input drum. And the reason why I want to mention that is because this is what I would call my input clutches retainer. It actually holds all the clutches, the underdrive clutch, overdrive clutch, and the reverse clutch. Or really, it retains the steels. But we call it the input clutches retainer because the steels and frictions live in there. The frictions connect to their corresponding hubs that drive the gear set parts. The steels lug into this input clutches retainer. So this is the part that receives torque from the engine through the torque converter. This is going to deliver torque to this input gear set. This is a piston. This is going to apply either the reverse or the overdrive, depending on which direction it moves. If you remember, we had this big apply plate, this big thick sucker that lives in there, and it has a snap ring that locks this basically to this piston assembly. So when this piston goes down, it carries this plate with it, compresses the overdrive clutch pack, and when this piston goes up, it carries that plate with it and compresses the reverse clutch pack. Okay. Living inside the input clutches retainer is the underdrive piston. So when fluid pressure gets behind it, it compresses the underdrive clutch pack. A lot of stuff going on. I understand that. It's kind of confusing. This transmission is extremely basic, but this is probably the only really complicated part of the transmission. It's not really that complicated once you understand it, but trying to figure it out can be pretty tough, especially when we're just new to transmissions. All right, so when we look at all these seals and these passageways, this is how hydraulic pressure finds its way into this assembly. If you take a look, I've got some holes, like that hole right there, and that hole is obviously going to feed pressure into this side of this hydraulic piston. So when I have fluid pressure coming in through that hole, it's going to push this piston up, which is going to apply reverse. So now you can understand what this hole does. It feeds reverse. And that means the seal that lives out here, and then this inner seal right there, has to seal off reverse. And then you might be able to guess that this hole right there, the one that's above the blue the one that's above the blue O-ring, that's going to end up pushing down on this piston. It's going to end up filling basically the cavity between the back side of this input clutches retainer. And the input clutches retainer lives in here. right in there. So when this is all assembled, this is in there. So it fills between the input clutch retainer, which doesn't move. It's splined and locked to this the input shaft, input hub. And when that fluid gets between the input clutch's retainer and the overdrive piston, it moves the overdrive piston down. That carries that plate, then applies that clutch. So, kind of looking at this drum assembly, that is the purpose of those oils, that hole right there. So this does separate the reverse and overdrive fluid passage. There's actually another one in the actual piston itself, another O-ring that fits in there. And then of course we've got the reverse seal on the outside here, and the overdrive seal is on the inside of the overdrive piston. A little FYI, this diaphragm type spring right here, you don't have to take it off. There's really no purpose in it. There's no seals behind it. You don't have to take it off to do anything. It actually works as a double return spring. When a piston's not applied, we need to have a spring to push it back to its resting position. This little diaphragm spring here is going to return the piston when it's applied in reverse. It'll push it back when reverse disengages. And then when overdrive is applied and then drops down into second gear and the piston returns, it's also going to return it. The same spring. And they use this is really brilliant engineering. The inner part right here, where the spring kind of overlaps, it's going to work on the hub. And then the outer portion, I'll show you that. I think it's pretty cool. But the piston, you can see it flexes that up. So every time this moves in towards the reverse, that spring deflects and then pops it back. The way it works in overdrive, if you notice, this surface right here is kind of machined on an angle, and then there's a little lip that goes around it. They do that on purpose because it's gonna push on this outer portion of that diaphragm spring. Going through more of this. So I said that was reverse. That was the feed for reverse. This is the feed for overdrive. And then these little holes right here are oil passage to get behind. And this is all assembled, and this input clutch's retainers on there. Those oil passages that are in there are going to get behind the underdrive piston and apply it. Brilliant. And lastly, this hole right here is kind of a lube hole to lubricate this bearing. We do have a couple other oil passages. They're used for torque converter clutch application. One oil passage will bring oil pressure out through the tip of the input shaft. That's going to push the piston back. And then if I bring the oil pressure around the input shaft and then I let it return through the tip, that's going to apply the torque converter clutch. Okay, so let's go ahead and put this baby back together. Normally in an overhaul you'd replace all these seals, and this is just a lab unit, so we're just going to go back together with it. So slide this in there. If it's not perfectly lined up, it's no big deal. You can get your fingers in there and straighten it out. Then if you remember, I'm going to take my big snap ring, I'm going to put it in there. If you look at the inside of this drum, they actually make a couple larger reliefs. That's the spot where these thick heads of the snap ring are supposed to go. When it's in there, I usually take a screwdriver, kind of twist on it a little bit, and help wedge that in there. Make sure that's got a good tight fit, because we want to make sure that input drum, that snap ring never comes off. Alright, so next I'm going to put my underdrive piston in. There are no seals on it. The seals for it are located right here on the input hub and also in that input clutch's retainer. So I'll push that in there. So next I'm going to go over to my foot press, and there's actually a tool to help guide this piston in, because we have a lip seal right here. And if I'm not careful, if I don't use that little guide, it could end up rolling the seal over when it tries to slide in there, especially since I'm using foot force and I can't finesse this in there very well. We're back over to our foot press. And kind of like when we took it apart, there's only one major difference is I have to use this protector here, because what that's going to do is it's going to guide this seal in there, this outer seal, and kind of collapse it a little bit so it slides in there and doesn't catch an edge. So I can't really get a good feel for this piston going in because it's compressing this spring while it's going in. I do want to center this as best as I can so that when I'm pushing this down it doesn't kind of go in crooked. Also, if you remember, there's kind of a crisper edge, like a little bit slightly rounded here, and then definitely more crisp on this side. So I want that side facing up so that way it seats into that snap ring groove real well. And there we have it. All right, following along with the service manual, we're going to go ahead and start putting these clutches back in. And also, following along with the worksheet, you want to make sure you're answering those as we go along. So we're going to start with our underdrive clutch assembly. They're going to have us start with the steel and alternate steel friction, steel friction. First time we go through this, we leave the input drums out so that way we can easily go in there and check the clearances of these clutches. And then if the clearance is good, then you just kind of take it apart real quick and put it back together. So the first snap ring I put in, and I should have left this friction disc out. By the way, the service manual really confuses the students with this part. They show you put in 3 frictions and 4 steels, and then you start putting snap rings in, and then they have you put a steel in, and that's like, students are always confused by that. Like, what's the deal? Where's this extra steel go? And they had you leave this steel out so that way you can put that snap ring in without potentially gouging this friction up. That's the only reason why they did that, but it does leave for a lot of confusion when you read that, because it doesn't really make sense why they have you do that. And then you put in your plate, your underdrive, overdrive reaction plate, larger step side down, so that would be this step. It's a little bit bigger. And actually, from the front, you can see that they bring this little step closer towards the center because they're giving you room to slide the snap ring in there when you're installing it. On this side, it's a thicker, wider plate because you don't have to make room to slide the snap ring in on this one. It's just got to lay down on it like that. Now when we go to install our tapered snap ring, we got our painted side going down, tapered side going up. That wedges that plate assembly in there, so now it can't move, it's not going to rattle or anything like that. And at this point, normally we would be taking our underdrive hub assembly and putting it in, but like I said, we're going to leave it out so that way I can go in and do a clutch clearance measurement real quick. You really can't squeeze a feeler gauge in there to check for the clutch pack clearance, so you need to use a dial indicator, and also we need to put a little extension on it so we can go down there. And what we're going to do is we're going to rest the edge of that the extension right on a tooth of the clutch disc. We can use a pick in there and grab the clutch and kind of see how much travel we got. Looks like it's about 50 thousandths. I could also use air pressure since I know my underdrive clutch. I almost went to 60 thousandths. If the clutch pack clearance isn't correct on this, I'm actually supposed to go in there and change this reaction plate on the top, put a thicker or thinner one, whichever one works. But it's going to be fine. All right, so now I need to put in my overdrive clutch pack. So then we'll put our wavy, the snap ring that has a little, looks like a truck drove over it. We'll put that in there. There's a little ledge on the inside of this piston that it sits on. It doesn't have a snap ring groove that lives in, so you got to make sure you don't get too carried away and push it like too far in. It'll actually kind of over collapse if you're not careful. And then we put our plate down on there. And then I put in my top snap ring. It's flat. This won't fit into the groove without me having to push down on it a little bit. I got it kind of tucked in there, but what I'll have to do is grab a screwdriver and push down on that plate. What I'm doing is I'm flexing that, I'm flattening that wavy snap ring down a little bit. But definitely make sure that's found its way in the groove all the way around. Now the same thing, I'm going to go in there, I'm going to measure my clutch pack clearance. You don't even need to use the pick on this one. You can just grab them and lift up because there's room to get your hand in there. So you can see I'm getting about 65 thousandths of movement. Compare that to specs, see if you're good. Now there is no adjustment for this one, so if this is off, you probably built something up wrong in there. Before I go any further, I'm going to go ahead and take this plate back off so I can put my hubs in there. Well, the reason why I left my hubs out is so I can gain access to these clutches to lift up on them and do a measurement on them. The reason why I can't just slide these hubs on there, there's these little tangs right there. Right there, there, and there. And they do that on purpose because when you go to install this into the transmission, if you spin this assembly over, the hubs will just fall out. So by having these little raised tangs in there, that prevents the hubs from coming out. So I have to, if I took this, since I put these clutches in there, I can't slide these down in there until I take the overdrive clutch pack out. Now I can go ahead and put my hubs in there. So the first thing I need to do though, is I need to put the Torrington bearing in there. The way you figure out how Torrington bearings go into a transmission is the Torrington bearings are designed to fit in one of two ways. They're either going to be designed to rest in a pocket, and if they're resting in a pocket, the outer race, I'm going to call this the outer race because I have an outer edge. I'm going to call this side of the Torrington bearing the inner race because it wraps up around the inside. This one's got a crack in it. Look at that. Would not want to put that in a live job. So if the bearing is designed to fit in a pocket, we would assemble it like that because that would let the outer race lay down in that pocket and wrap up around the outside. If it's designed to fit in a shaft or on a shaft, we would want to do it the other way. Like I'll use the sun gear as an example. There's not really a shaft on it, but there's this raised section that goes all the way around it right here. So it does have a machine pocket, but the bearing doesn't fit tight with this outer pocket is much greater than the bearing diameter. So it's not designed to fit that way. In fact, you'd have to force it to go in that way. It'd be way wrong. But if I flip this over, you can see the inner race fits tightly with this shaft. It's kind of designed to fit in around the shaft there. And by the way, we're just learning this, but this transmission, that little bushing that lives inside here, we'd want to definitely change that out. That's one of the reasons why these things fail. Of course, we're kind of focusing on this transmission is just learning the basics. Okay, so next I'm going to go ahead and remember this is the one that has the dual, like two thrust washers that are contacting each other. This has got 5 teeth and they sit right there inside this input hub, the underdrive hub. And then this is the one that fits on the back side of the overdrive hub. Smooth one, it's got 3 tabs that sits on there. And this is my selective washer. And this selective washer I wouldn't necessarily have to change unless my end play was off for some reason. Now I can go ahead and put my clutches back in just like I did when I did the measurements. The reason why, like I mentioned, that we redid this is because I needed to gain access to do the clutch pack clearance measurements. So with this snap ring in and everything, you can see I can't pull that overdrive hub out because those little tangs keep it in there. That's a good thing because when we go to assemble it and we drop this in, we don't want all these parts falling out. Before I put my reverse clutches in, if you remember, somebody ruined this reverse clutch, so I have to put a replacement one in there. We put the friction steel, friction. We'll put our plate down in there. You actually have to push this plate down to gain access to the snap ring groove. Students sometimes come to me about this. They're like, yeah, I put this in, but now there's no clearance in my reverse clutch. But they forgot that they had to push this plate down to get that snap ring in. So when you're done, you need to lift that plate back up and seat that plate. And you can do it one of two ways. You can use a screwdriver like I did, or you could pump air into the clutch assembly and let the piston push it up. All right, so now that I've got this seated, I can go ahead and check the clutch pack clearance on the reverse clutch. So we're getting about 20 thousandths clutch pack clearance on the reverse clutch. Seems kind of tight. It'll wear to fit. Sometimes I'll push down on the clutch a little bit before I lift it up just to see if there's springiness to it. We're getting right about 30. If the clearance isn't quite right, the snap ring is what I would change. They come in different thicknesses. All right, so at this point my input drum's built and I can put it off to the side. And next we're going to take a look at the oil pump. The first thing we're going to do is take these 13mm bolts out from around the pump. Then we can split the pump halves. There I have the pump apart. We see the gears. There's an outer gear and an inner gear. This is the little crescent that it has. And this surface, a lot of students will look at the disassembly, and sometimes these little check balls that they have in there, they think they can come out, and they don't. They just use these check balls to plug off the passages when they're doing all this cross drilling to get the oil pressure to where they need to go. And sometimes those check balls stick up a little bit, and then when they grind it, it looks like they're ground flat, and they think something's wrong. A lot of times students will also comment on this discoloration that's right here, and they'll think that overheated. Actually, this is just a hardening that they do to the splines because they force that in there. And you can kind of see the splines in there that they're just making this assembly hard. So there's nothing wrong with that. When we study the hydraulics, you're going to hear the term about dribbler circuits. And there's little check balls behind those springs that are in the dribbler circuits. If I shake this, you can hear them in there. I don't know if you're able to hear that through the microphone though. All right, so there are a few measurements. We can obviously inspect this gear set, visual inspection. We could take a look at the gears and make sure they're not pitted. I like to try to keep them in the same direction, the same orientation. So you'll want to note which side was facing up when you took it apart so you don't flip that. On some of these gears, it's essential that you identify which direction is up because the lugs, the parts that the torque converter drives, might not be equal. It could be offset one side or the other, and then you would definitely need to know. So you want to inspect the surfaces to make sure they're not scored or galled up. Same thing with the pump halves. Now this pump looks brand new. It is standard practice to change these bushings out. You can see this bushing staked in there so it doesn't get spun. You will put a new seal in when you're overhauling a transmission, the front seal. If you don't, you're asking for a leak. Now the measurements that we do on this pump to see if it's any good, there'll be a couple different measurements that we perform. So there's a few different clearances that we're going to check on this oil pump. We're going to check between the outer pump gear and the pocket. We're going to check between the outer pump gear and the crescent and the inner pump gear and the crescent. And then we're going to check this side clearance or end play, basically the up and down movement that this has in here. And I got my assortment of feeler gauges out here. The side clearance or end play of this gear is supposed to be like between 0.8 and 1.8 thousandths. Obviously you don't have feeler gauges that measure that fine. I don't. You could probably use plastic gauge like you use on an engine. Lay that in there, bolt the two halves together and open it back up. I'm going to use a straight edge off of the square that I've got. It's a machinist grade 1. And you want to check to see, make sure you don't have anything underneath it. You want to check to make sure that you cannot fit That was a 1.5 thousandths feeler gauge, and it did fit under there. I'm going to try my 2 thousandths. That's about as close as I got to 1.8. And it also fits under there. It fits between the inner gear, but not the outer gear. So I actually have a little bit of excessive side clearance on my inner pump gear. Another measurement they want you to do is between that outer pump gear and the pocket. And it's allowed to be as high as 8 thousandths. So I'm going to start with 4. Sometimes these feeler gauges stick together. 4 fits in there. 5 fits in there. 6, so it's about 6 thousandths. And then my outer pump gear, the crescent, I think is allowed about 15 thousandths of an inch. So I could try stacking a few of these together, or I could pull out a 15 thousandths, I guess. Not be too lazy. Usually I just go up towards the high end of the spec. If it doesn't go in, then you know you're good. And it does not go in. And I think this inner pump gear to the crescent is 11 thousandths max. And it does go in, but what I'd be best off doing is putting this on the torque converter to let it center this gear, because there's a little bit of obviously movement. The torque converter is going to center it to the bushing. I think that'd be a more accurate measurement. So those are the few measurements that you'll do and you'll have to fill out in your worksheet. They involve the oil pump. And if, when we're done, as long as there's nothing major wrong with it, we're just going to go ahead and put it back together. There is no special tool to align anything with this. A 41T, some transmissions you're going to see that there are alignment tools for aligning pump halves. They don't have that on the 41TE. You can go ahead and run your bolts in and torque them down, torque them to spec. Now that we're done inspecting the oil pump and taking apart and putting together the input drum, the next thing we're going to do is start putting things, we're going to start going back together with it. So this first assembly that we have to install is our output gear set and the output gear. And if you remember when we took this apart, this is what we hit with a hammer to kind of get it out, because there's a little bit of an interference fit between this gear and the splines. They don't just slide in and off very easily. But don't forget there was this output shim. You got to make sure that's in there, or else without it, you're going to squeeze these together and you're going to end up binding this up. It's going to end up getting too tight and you're going to over clamp these bearings. So I'm going to go ahead and spin my transmission around. Remember, this thing is kind of offset to one side, so it's awkward and heavy. By the way, the transfer gear here, it works with a slight amount of end play, which I really can't feel any. Whereas this output gear works with a slight amount of preload. So if you were overhauling this thing, and really if you ended up changing, like most people are going to reuse this shim, unless for some reason you changed this housing or you changed the transmission case. Or if you had a noise concern, if these bearings failed or something like that and you really didn't trust how it was set up. If you were to go through and do this thing from, like after changing a housing or changing a gear set, they have you basically put this assembly in there, tighten it down, measure the rotating force, and it should be within a certain spec. I don't know, it's not high. It's probably 5-10 inch-pounds. And if it's off, if it's too loose, if it doesn't have any preload, you'd put a little thinner shim in there. If it has too much preload, you'd put a little thicker shim in there. But if you're overhauling this thing and you didn't have to change this part, or you didn't have to change the housing for some reason, there's really no need to go through and check that, because it's not going to be any different than what it was. And really just changing the bearings, you wouldn't need to change it either, because bearings are not going to make that much of a difference. They are very tight tolerance items. Okay, so I know I have my washer on there, my spacer. I was just staring at it. And now also another thing, they've got this kind of a cone-shaped washer, and you want to make sure that this goes with the dish facing down. It's kind of a locking mechanism they have. I don't know how effective it is, but I guess it distorts when you tighten it, and then that prevents this from loosening up, possibly. They do provide these little holes in these gears So if you have a yoke holder, you could just hold it there. You really only need to do that if you take this transfer gear out, because you can always use the parking pawl to hold it in place. And most techs are going to just go ahead and blast it together with an impact gun. Here, since this thing just basically goes together and comes apart, goes together and comes apart, we'll just tighten this thing up. We don't have to go to the torque spec. The torque spec is pretty high on these. The torque spec is 200 foot-pounds, so we don't need to go 200 foot-pounds for these lab units, but once again, obviously, if you're overhauling this transmission and this is for a live job, you definitely want to put it to the torque spec. Now that I've got this bolted down, I'm going to use this bolt retainer. And really what this is doing is it allows me to use the gear puller threads and this little bracket assembly to kind of tighten a retaining mechanism to keep this nut from ever loosening up, which is probably a good idea. They didn't always have that. That wasn't something that the earlier units had. At this point, my gear's in. Now, in a live situation, we would fold these tabs up, and you'd actually want to get a new retaining mechanism there, because these could break off. That would be bad to have that get caught up in a gear or something. Okay, so I'm at that point where I can flip this back around carefully. All right, so I need to start putting these clutches in the case. And these are my case clutches, my holding clutches. I got the low reverse and the 2-4, the piston that applies the 2-4. So I can start putting this assembly together. I'm going to start with a seal friction So like we saw with the plate and the input drum, there's actually two steps. This one's very slight. This one's a little deeper. This is the side that goes down. This has that little bit of chamfer on there, so it allows us to get that tapered snap ring on top of it. Like the input drum, this is that part of the service manual that could confuse some people. If you remember, they had you leave a friction out, so that way you can get this flat snap ring in there without risking damaging the friction disc. So, and this is also worth mentioning at this point. When you go back together with this, they want you to put the snap ring openings in a certain spot. So they got in the service manual a little picture, and it says flat snap ring end between the 2 and 3, and tapered snap rings between 9 and 10. I don't know if you got that wrong, what would really happen, but they want you to do it. So now that's referencing 12 o'clock. 12 o'clock would be up here. And so I need to go between 2 and 3 with this flat snap ring. So I got my flat snap ring down there, but remember, before you put that plate in there, you got your friction disc that you purposefully left out there so you can tear it up, putting that snap ring in. Then you can put your plate in there, 2-4 low reverse plate, and then I'm going together with my tapered snap ring. Remember, painted side down. A little bit of paint left on there. Almost looks like rust. And then my tapered side goes up. You can see the light glistening there. There's a taper on the outside edge. Then I need to put it between 9 and 10. AM or PM? If you remember, I struggled trying to get this out of the case because whoever did it last put it together upside down. Now that I have my clutch in there, I need to check the clearance. And if you look, it's pretty difficult to get to things. But what I can do is I can go ahead and use my dial indicator, and I'll use a long extension on my dial indicator so that way I can get down in there, rest it on a friction disc, and be able to see my dial still. The hardest thing is making this stay on a clutch disc while you're checking this and not knocking things all over the place. I'm kind of pushing down on it a little bit like I did in the input drum. got about 40 thousandths clearance. All right, now that we've got that installed, we're going to go and move to our 2/4 clutch assembly. Now if you also, don't forget, this is the one where we had those staggered, we're supposed to stagger our steels. You can see there, there's a stagger to it. If I flipped one of these around, you would see they would be the same length right here, that little pad. Flip it around that way. It's supposed to go stair-step like that. And the reason why they do this is because they have shutter issues. And one of the things that they changed is, when you build it, you're supposed to stagger your steels, but also you're supposed to use Borg-Warner frictions in there. And these are Borg-Warner, it says so right on it. Borg-Warner. So this was actually in a service bulletin that said, make sure you, they said first do a software reflash. If that doesn't fix it, take your transmission apart, stagger your steels, make sure it uses Borg-Warner frictions. So I don't know, why not just, if you build one, just make sure you have Borg-Warner frictions the whole time, all the time. Okay, got the frictions installed. Next would be to install the housing in the piston. This piston could be a single molded piece piston, or it could be an aluminum one like this. Either way, you need to either change the piston or change the seals. The very early ones had lip-shaped seals, and then they discovered that lip seals were bad about shrinking and then not sealing. So throughout this transmission, they changed the seal type to these D-ring type seals. The D-ring shaped seal is kind of like an O-ring. It's squared on the inside where it fits into the groove, but the outside is rounded and there's no lip to it. It does fit a little tighter. And then we have a D-shaped inner seal. So even if you were to rebuild an old one, you'd want to go back with D-shaped seals, the D seals. You want to go back with D seals. They also do have at what would be the 12 o'clock position in the transmission, there's like a hole. And the very early ones didn't have that. And I still remember the first time I was overhauling one of these things, that this was one of the clutches that used to air test tight, like thunk, you'd hear no leakage. And then I had leakage and I took it all apart and I looked and I'm like, what the heck? They've got a hole in there. And that was something they changed and they added that to it. So I thought there was something wrong with it, but no, that was actually done on purpose. Now when I put the piston in, I line up one of these holes with this little kind of tab that sticks out, because that makes it a little easier for me to figure out where the fingers are on this diaphragm spring, because I put everything together this way down, so I don't really see the openings. But if I know that I've got an opening lined up with that tab, ow, just pinched my finger in there, and then that tab is lined up with this spot in the case right there, I can lay the spring down with one of the tabs lined up with that, and then I can lay my housing down on top of it. And I know it's going to be centered over that spring. So this is where you're actually supposed to use a special tool. The snap ring groove that retains this housing is slightly below the surface here because of that dished spring. So I need to go in and push that down. This is the tool. It's been modified because what happens, and it's still bent, what happens is the students, they think they have to get a wrench on this to tighten it down. It only has to go down about a 1/16 of an inch. So you put that in there, and when you run, man, this thing's threads a mile away. So what happens is they end up getting a wrench on the end of this thing and totally tightening it down. And I mean, look at that. This is the bar that rests across the transmission case. All you can do it with your hand force. You don't even need, I don't know. I need to probably bend that back. This takes skill, by the way. Not everybody can do this. I don't even know why it was unthreaded so far. You don't need a lot to hold that down. Really, we could just do it with this set of welding clamps here. These little slots are there so you can put bolts in, but then you have to find bolts that'll fit in there. But since, like I said, it does not take much force, You can get it done with just something like a couple welding clamps. Hand force is all you need. I just did that with my bare hands. I'm going to put my flat snap ring between 2 and 3, like they had us do, the bottom one. So at this point I got my low reverse clutch installed on the bottom. I just installed my 2/4 clutch. I still need to do a clearance measurement on it. So I'll go back over to my trusty dial indicator. Looks like we're going from 80 to 30 maybe? 50 thousandths. So we'll compare that to spec. Now here's the thing, if that is wrong, if that's out of spec, there's something wrong with the way I built it up, or there's some improper part in there, because there's no adjustment to that. Where the low reverse, if it's wrong, you can change it with different thickness plates that go in there. That 2/4 clutch assembly has a huge spec clearance. It actually goes from 30 to 100 thousandths. At this point we have our clutch packs in there, and it's worth going through and air testing it at this point to make sure it's sealed. To air check the 2/4, it's actually really easy because the valve body pushes up against this hole. There's a seal there, and see, that actually seals real nice. You hear that leakage, but that leakage is coming out of that hole on the top. So you're actually expected to have some leakage. Now when I go to air check the low reverse, I have to put my finger over this hole because that's the low reverse accumulator. And if I push air into it, it's just going to come out through that hole. So put my finger over that hole. Whoa. Nice solid. You hear a little bit of leakage, but it also has a bleed orifice. You can make some a mixtape. Yep, it's wiggity wiggity whack. So these clutches air checked out real nice. You heard the leakage, but that's not a big deal because they do have those bleed orifices in there to let fluid out. Really, on these holding cases, it's there to purge the air out. So when they have hydraulic fluid going in there, there's got to be a place for the air to go, so it purges it right out through those little bleed holes. And also, that's the reason why we check these at 30 psi. It's because we know it's going to have leakage, but as long as that piston's applying, we can tell it has a sound apply to it, that the clutches are good and the seals are good. It's also worth noting that we don't want to air check anything unless we have something for those pistons to work against, like a clutch pack that's in there. We don't want to go through and air test it without clutches in there because there's nothing to limit the travel of these pistons. And one of two things could happen is if I didn't have any clutches or steels in there and I actually apply air to like this input drum assembly or to a case clutch or to the piston in the case, it's either going to flex up to the point where the seals pop out of the bore, and one of two things could happen is, well, you can get lucky and nothing bad happens, but the piston return spring is going to push that back down when it loses that pressure. Once the seals come out, pressure's gone, piston return spring is going to try to push it down, and it might cut your seals in half, your brand new seals that you just put in there. Another bad thing that can happen is that if this thing could travel all the way up to the point where when things like the retaining clips or springs that hold the return springs down, they're not really meant to see the full force from a piston coming up against it. They're there just to only retain the spring. So now you got this piston with a lot of surface area behind it and all this air pressure, and it's working across that whole surface area. All that force working against a snap ring groove or something like that can break that off, cause some damage to the transmission. So long and short, if you're ever air testing anything, make sure the clutch has something to work against. Now there may be some situations here and there where you can't do that because the clutch assembly's on one half and the piston's on the other half. In those situations, you're just going to bleed a little bit of air in there to make sure that that piston has a seal. But otherwise, the vast majority of times, you never want to air check anything unless there's a clutch pack in there to work against. So at this point, I got my clutches in there. I've got my output gear. I'm going to start building my gear set in there. I've got my rear sun gear. I'm going to put that in first with its little Torrington bearing. And then I've got, oh gosh. And then I've got my rear internal front carrier assembly with its Torrington bearing. I'm going to put it in there. Now I have to spin this assembly in, and that can be difficult at times. This is one of the parts that students fail to get in all the way, and then it holds the gear set up, and that prevents the pump from sitting down flat. I think I'm down all the way. It's pretty close to the annulus gear, or the internal gear, is pretty much flush with the edge of this piston. And if I stick my finger down in there and try to pick up on the sun gear, I got no movement. I can't lift it up or down. So I'm going to assume that's in all the way. Next, I'm going to take my front sun gear. Same thing. I got to line up these frictions. Let it drop all the way in. Trying to line up the 2/4 clutches right now to this drum. And if I can spin it and hear grinding sounds like that, I know I'm not lined up. I'm fighting one friction right now. One little trick is if you didn't get that rear annulus front carrier assembly all the way down where its splines are on the low reverse, if I use my air nozzle and I air check reverse again, if I see that whole gear set assembly lift up and down, you know I'm still hanging up on one of those clutch discs. So not a bad little test to do. And it's good, so it didn't move. That doesn't really help you with the 2/4 clutch pack because the 2/4 clutch pack is pushing down. But I've got this all the way down in there, I believe I do. So for the next step, we're going to take our input drum and we're going to go ahead and put it in. Got to make sure I have my thrust washer sitting there and I got my selective spacer right here. So I'm going to go ahead and drop this assembly in. Now this is the trick to make sure you have everything lined up that you'll do before you put your oil pump in. This tone wheel right here that has 60 teeth on it, the input speed sensor reads right off of that. I'm going to take a peek through the input speed sensor hole, and this should be smack dab in the middle of that hole. If it's not, then I don't have something in all the way. Because right now at this point, I just lay it in there, I still have 2 reverse frictions that I have to line up and to drop in. And I felt like I just dropped in past both of them. How about that? We're going to call it good. If we see it offset more towards the pump side at the top as we're building it, then we would know that we don't have it in all the way. We're looking right through that speed sensor hole and lining up the tone wheel up against it. So I got my input drum in there. Next I'm going to put my oil pump in. And there is a Torrington bearing that goes between the pump and the gear set here, and it's designed to fit kind of like this. There's a little ledge, can't really see it down in there, but so it's designed to fit around the inside race of this Torrington bearing. Go ahead and drop that in. Students sometimes put that in backwards, and then they end up crushing that when they put it back together. Before you put the pump in, make sure you don't forget to put the cooler bypass valve in. And if this transmission generated any metal from its failure, hopefully you're putting a new cooler bypass valve in. I don't want to forget my gasket. Make sure that seal's on there. And line this pump up to the holes. You might, there are guides, we don't use them, where basically you can put these guides in there that allows the pump to slide perfectly down in alignment. You can peek through the holes and do a decent job. What I usually do is let it just fall in there and gingerly line it up. Then I get my pump bolts. The pump bolts have these brass washers on them. You would obviously change these. They crush a little bit and seal off. But I'll usually just get these kind of started. I don't tighten them down with anything yet, but I make sure, because you can actually grab them and wiggle them, that helps kind of center this pump. I'll take the handle of my hammer, kind of go around it, and let it seat. To check things, I'll just snug up too. And if, when you go to tighten this, it doesn't snug up immediately and it seems like you're drawing this part down, stop, because you probably don't have something lined up and you're probably bending something. But this thing went and the torque built up immediately. So at this point, I can check my input shaft end play. It's at about 10, and it goes from 12 to 22. I'm getting about 10 thousandths end play. Not bad. I think the spec is like 5 to 25. So that's an improvement from when we took it apart. Went from 0 end play and a crushed reverse clutch disc to I fixed the reverse, and now I have 10 thousandths end play. So at this point our pump is done, our gear set, everything down to the bottom. We just need to torque, snug up and then torque our oil pump. At this point, everything from the pump down is completed. We've got our oil pump torqued. We've got 10 thousandths end play. All the clutch pack clearances are good, and everything air checks well. So if I had an issue with this transmission, I'm pretty confident that everything here down is good. So I would focus on things like my valve body or my electronics. Depending on where you're at in the class, we might have a chance to go through the valve body. Hopefully everybody will get a chance to go through the valve body. But if you're a little slow to go through all these other things and time's running up, sometimes we just kind of keep the valve body back together and then hit it on another transmission. But we're going to go through this, and with the expectation that everybody's going to have the opportunity to go through this valve body. To protect it, let's go ahead and pull this range sensor off first. We don't want to crack that. Pull on that spring a little bit, you can lift it up, we just kind of put it off to the side. But if you remember, the whole purpose of this was so that way when you're switching between gears, that the computer can determine what manual valve position you're in. And it does so by looking at the buttons here. They're going to close switches, and they're also going to make contact with this metal plate, which will end up getting grounded. You can see parts of it are plastic and parts of it are steel. So kind of a neat little switch assembly. And then right here is the temp sensor. They put the thermistor in there. This seal right here makes the connection between the 2.4 clutch housing and the valve body. So they'll give you that in a kit. Definitely don't want to forget that, because it's just going to leak out. When we bolt the valve body onto the housing, that kind of deforms and squeezes up against it. I'm going to flip it over, and we're going to get all these Torx bolts out of here. Okay, now that we've got all the Torx bolts out, we'll go ahead and pull this half off. This is a spacer plate. Now in the basics lecture, when we were talking about orifices and so forth, that's where they locate these at. There are tons of these tiny little holes, like right there, 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 there. These are all orifices that are engineered to a certain diameter to control flow, how quickly fluid can get into a circuit, or they're feeding some kind, or they're feeding the end of a valve and dampening how that valve reacts. This half of the valve body doesn't contain any real valves. It does have this little check valve assembly, and it has a thermal element right here. So this is a bimetallic spring, and it'll actually change the size of an opening with temperature. And then we also have a filter. And then right here is our valve body. As you can see, I've got a check ball right here. They're little plastic check balls. And they come in kits, so you can replace those. There's another check ball right there. There was an empty spot right here. And then there's a check ball right there. I can get it. So we've only got 3 check balls in this valve body. I also have this little plate covering my 2.4 accumulator assembly, so I can go and pull that off. So there's my 2.4 assembly. If you look, it's got a double spring, kind of like the low reverse piston did. Natural colored. And there's the piston. This valve body is, like I said before, like the simplest thing in the world. They don't have that much going on in there. They've got a pressure regulator valve lineup. They've got a manual valve, which is this one. The manual valve lives in that bore. This bore has what they call a solenoid switch valve. When you look at the hydraulics PowerPoint, you'll see the purpose of the solenoid switch valve is so that one of our solenoids can operate not only the torque converter clutch, but it can also operate the low reverse clutch. They figure the low reverse clutch is only on in first and reverse, and otherwise that solenoid would be off most of the time. So why not shuttle a valve once you get in the second and allow that same solenoid to operate the torque converter clutch? So that saves a little bit of hardware and saves the solenoid and probably some hydraulic circuits. And we have two torque converter valves in here. One of these is going to be to control whether we're in the apply or release mode for the torque converter clutch. So they call that the torque converter control. And the other one is the converter clutch control, which kind of sounds like the same thing, but the converter clutch control valve is really there to control how hard or soft the torque converter clutch applies. Converter clutch control, torque converter control, manual valve, solenoid switch valve, pressure regulator valve, and then they do put an extra regulator valve in there just for the torque converter pressure regulator to regulate overall torque converter pressure. This valve didn't exist in the very early units, but they added it. So they went from a valve body that had only 5 valves in it, and they added another one, so they made 6 valves. Once again, the simplest valve body in the world. As far as tests that we do, you can disassemble a valve body and you clean it out real well to get all the oil out of there. And then we want to make sure these valves move freely in the valve body. That's one important thing. A lot of people would at this point go in there and they'd use a pick to go through and pick the valves. Make sure that if you can move a valve in one direction that it returns, as long as it has a spring to return it. And but what we can do is we can clean it out and we can reassemble it, and then we can check to see if any of these bores are worn out. That's something that can happen to these aluminum valve bodies with aluminum valves that ride in them, is these bores will end up wearing out and then fluid can leak around the valve and the valve body bore. So what we do is we actually pump vacuum into some of these sections to see if there's an excessive leakage. And I'll show you that here in a minute. Okay, so I went ahead and took this apart, laid all the valves out on my valve body tray, which is always a good idea to do so that way things don't move around or get mixed up on you. And so this is the valve body stripped down, went ahead and cleaned it out, got all the oil out of it. And right off of this tray I could sit there and spray some brake cleaner on or solvent just to kind of clean the oil off of it. You want this oil free when you do the vacuum check on it, because you don't want oil acting like a seal between the valve and the bore. You want both of these clean and dry. So really your best bet is to clean it off with brake clean, both halves, so that way it's free of oil. Now I'm going to go ahead and put this valve body back together. We'll see how well this goes. All these valves should fit in there smoothly. That you shouldn't have to push anything in there with force, excessive force. I actually have a special tool to help you install this. It pushes in on both of those valves at once because you've got this kind of double plate retaining both of them in there. Okay, at this point my valve body, minus the manual valve, but my valve body is back together. So I can go through and I can do a vacuum test on it. Okay, we're over here where we do vacuum testing. And like I mentioned before, the idea is we're going to go in and we're going to pump vacuum through these passageways and see if there's excessive clearance between the valve and the bore. And I use an old air conditioning vacuum pump. Got a couple valves that we have here. And on these valves, you'll see one side says 5, the other side says 25. You probably can't see it from where you're at. And those are the values that we calibrate this to. So while this is running, and I take the end off of here, the little tip. This is a homemade setup, by the way. So when we go to calibrate this and we start it, we're going to put this little rubber piece on there. Inside there's a little cup plug that's got a 40 thousandths hole drilled in it. So we're going to make the vacuum pass through a 40 thousandths hole. And while it's doing that, we're going to turn this dial until it achieves 5 inches of vacuum on the gauge. Then I'm going to put my finger over the end of it, and I'm going to see the vacuum climb up, and I'm going to adjust this dial until I get 25 inches of vacuum. The reason why we do this is because it allows any vacuum pump, a real strong one or a moderate one, to basically read the same on any valve body, so that way we get consistent results. So we're only expecting a full perfect seal to be 25 inches, and then we expect a 40 thousandths leak to be 5 inches of vacuum. And anything in between, a perfect seal and 40 thousandths worth of a leak, it's going to be anywhere between 5 inches of vacuum and 25 inches of vacuum. So let's zero this out. I got 5, put my finger over it, a little more than 25. So there's 25 and 5. What I'm going to do is use these valve body charts to identify the passages that I need to check. And I will use this plate that's got a little rubber gasket to lay over those passages. The first one I'll check here is the converter clutch control circuit. It says I should have 17 inches of vacuum. I got 22 inches. That one's plenty good. Then I need to check here, which is that accumulator, like that solenoid accumulator I talked about. It's got 20 inches of vacuum. It's supposed to have 17 minimum. Then I'm going to check my regulator circuit, my torque converter clutch regulator circuit. I got 18 and it says 16 is what I want on that. Now I'm going to go ahead and check my pressure regulator circuit. I got 18 and it says I should have 18. Then I'll check this other section of the pressure regulator. I'm getting 14 and it says I should get 14. And then lastly, I'm going to check my solenoid switch valve right here. I got 18 and it said I should have at least 16. And then this other portion of the solenoid switch valve. And I've got 14 and it said I should have 16. So the only one that failed was on the solenoid switch valve right here. It said I should have gotten 16 inches and I got 14 inches. Still pulling 14 inches of vacuum. When you think between 5 and 25, the midway point would be 15. So I don't know if you could do the math this way, but that would be the equivalent of like a 20 thousandths of an inch hole, which is pretty small. So that might not actually cause a problem, but that's the spec, and that's the spec that we're working off of from Sonax. Okay, now that we're done vacuum testing this valve body, we can go back together with it, finish this off. And don't forget, we've got 3 check balls in there. The service manual will show you which passages have the check balls. But it's going to be these 3 right here. Actually, our worksheet has that too. Unless you have a really old unit that all of them are going to have 4 spots but 3 check balls. So I put a little trans gel in those check ball spots so I can stick them in there and I know they won't move anywhere or fall out. Then at this point I can go ahead and start reassembling this valve body. Now that we got this valve body back together, I don't know if you noticed, but this did not use any valve body gaskets, just used the steel plate. For that reason, a lot of rebuilders, before they put these valve body halves together, they have a granite block with sandpaper on it, they'll sand it, they'll keep sanding it until they know it's perfectly flat. They'll do that to both sides. And the reason why they do that is they want to give it the best chance of not leaking. You know, they've got tons of valve body bolts, as you saw, but we want to make sure that we torque those and start in the middle and spiral our way out so we give it the best chance of sealing. Another thing that's worth noting is that this parking pawl assembly right here, if If you look, it's not symmetrical on each side. And if you also look, there's this little tab right there. You want to make sure that tab finds its way underneath this bracket. If you have that flipped upside down, it will still go back together in the transmission, but you'll only get like park and maybe half of reverse or something. You won't be able to shift the shifter all the way. It won't be able to find its way through the parking pawl. So at this point, we're ready to put this valve body back into the unit and start finishing this thing up. All right, we're on our final stretch. We're almost done. I could have put this end cover on earlier, but I'll do it now. Normally you obviously clean the pan off and put a fresh coat of RTV on there. You don't want to get too carried away with the RTV, so you don't want it all end up in there and clog up oil passages and find its way into the valve body. Before we put the valve body in, we need to deal with our accumulators. If you remember, the low reverse was the only one that went in spring first, and it had the double spring, and then the piston, and then the underdrive and overdrive accumulators, they go in pistons first and then springs. I got to put my cover in. I want to make sure the little dimple is facing out. Then I can put my snap ring in, sharp edge facing out. And I could go through and air test that to make sure it seals up fine right through the low reverse passage. Now actually we're sealing off into that accumulator area. At this point we need to put the valve body in, and I'm going to say it again, let's make sure that that clip is around that bracket. I don't know if it matters, but the ones that have 100% thread on the bolt seem to go into these 7, and then all the others that have a shoulder kind of go around on the outside. Now we got to go ahead and put our oil filter on. Now we're ready for the oil pan. Of course, if this was a live job, we'd put a fresh coat of RTV on there, clean the old stuff off, and put the new stuff in. The last things that we have to do are put our solenoid pack on and put our speed sensors in. Then we're done. At this point, we've got it all buttoned up and we're ready to test it on the dyno. One thing that's worth noting is obviously this was a lab unit, so I didn't take it completely apart like the final drive and the transfer gear. You'd want to do that on any overhaul. Also, standard in any overhaul is going to be replacing all the rubber parts, any seals. In most cases, you're going to change all the frictions. The steel plates, only if they're burnt or warped or scored, but a lot of times you'll reuse steel plates in there. And of course with the valve body, you'll go through and inspect it like we did with the vacuum test. You'll either have to bore out and put in fresh valves, usually aftermarket valves like Sonex valves, or you might have to put some manufacturer's kit in there like Superior, Transgo. There's a number of kit manufacturers that are out there, and they design kits to basically accommodate any kind of wear that might occur in the valve body by doing simple modifications. So anyway, typical overhaul would include those things. This is, like I said, basically showing you the process of going through the transmission. And every transmission we go through, there's going to be some similarities, but there's also going to be some unique things that are going to be different between this transmission and the other ones that you might go through. So now that we're done with this one and you finish all your worksheets, finish all your lectures, and take the test on it, then we'll move to the next transmission.